Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. Today, we are going to complete the test, the Regents exam of geometry for January 2026. So we have parts 3 and 4. These are 4 problems. We will start with part 3 that has 3 questions, and each one is worth 4 credits. In this problem, they say an isosceles triangle ABC below and AD is an altitude drawn to base BC. Okay, so we know that these two sides are congruent and as well as these two angles. If angle BAC is 80 degrees and AD is 8, determine and state the perimeter of triangle ABC to the nearest 10th. Okay, so we know many things. We know, for example, that if I have an isosceles triangle and I go to the vertex and draw a line perpendicular to the base, that, first of all, it's 90 degrees, and then it would split it into 2 halves. Exactly, so it bisects the base, right? Now, we know that this is isosceles, so it's 8, and also a vertical line will bisect the angle, so this is 40 degrees and 40 degrees. And if we know this angle, and or you can use also this is 50 if that's 40, right? You don't need that, but so now how do I find this base? Because basically, find the base basically, okay. You can either use this angle or that angle. Notice that this, if I use this angle, then cosine of 50 is adjacent over hypotenuse, right? And if I use this angle, then CD would be opposite over hypotenuse. So either sine of 40 or cosine of 50, it doesn't matter. So that you have 2 ways to do it. Let's say we are going to say that segment CD equals 8 cosine 50 degrees or 8 sine 40 degrees. We know that complementary angles, the sine of one equals the cosine of the other. So 8 cos 50 is 5.14, and they don't have units. Okay, so now BC, since D bisects BC, then BC would equal 2 times 514, and the perimeter would equal 8 plus 8 plus 2 times 514, or this would be 10 point, so they want it to the nearest 10th, right? So we multiply that by 2 and add 16, which are the 8 and the 8. So you get 26.3 to the nearest 10th. Okay, so that's one of the 3 problems. The second one says in equilateral triangle, in a quadrilateral, oh my God, quadrilateral SMIL, that's why I smiled. Below, diagonals IS and ML intersect at point E, and MS is parallel to IL and congruent to IL. Prove that triangle MIE and triangle is congruent to triangle LES. So these 2 triangles. Okay. So we start with the statement and the reason. You call it statement and reason? In our schools, we didn't do that. It's completely different. I don't know if the French still use the same as we learned, or they are doing it like Americans now. Anyway, so statement number one, which is the given that quadrilateral SMIL has segment MS is parallel to segment IL, and segment MS also is congruent to segment IL. So this is given. Okay. Number two. So now we are going to try to do this. First of all, we know that if I have a quadrilateral with two opposite sides that are parallel and congruent, then this must be a parallelogram. So we can say SMILE is a parallelogram. And here we can say that quadrilaterals with two opposite sides that are parallel and congruent is a parallelogram. This is important because if that's a parallelogram, now I can say that MI, segment MI, is congruent to segment LS. Why? That's a property of a parallelogram. Opposite. In fact, and ML also is parallel to segment LS. Opposite sides of a parallelogram are parallel and congruent. Well, here I drew it and here I wrote it, but doesn't matter. So now we know that I have a side. Okay, well, we can, for example, find these two angles, so EML and ELS. So the measure of angle EMI equals the measure of angle ELS. And we can also say that, so this angle and that angle, and we can also say the measure of angle EIM equals the measure of angle ESL. And both of these are alternate interior angles are congruent. We established that ML, no, it's MI. Why did I say ML? I'm sorry, MI and LS are parallel. So these two angles now and those two angles are alternate interior are congruent. So their measure is the same. So now we can say that triangle EIM is congruent to triangle, say EIM, so ESL. Angle side angle. And that proves that, well, I wrote it ESL, so you can write it MIE and LSE. And that concludes the proof, right? Mathematicians like to do something like that at the end. So yeah, that's the first one. Am I missing one again? Oh my God. That's 33. Did we stop at, no, we did 32. Oh, we did two. I thought this was the first one we solved. I'm sorry. Getting old. Okay, number 34. You can't. A solid glass trophy is composed of a rectangular prism and a rectangular pyramid, as modeled below. The rectangular prism has a length of 12 centimeters, width of 6, and height of 3. The height of the pyramid is 10 centimeters. If the density of the glass, is 2.5 grams per cubic centimeter, determine and state the mass of the trophy in grams. Okay, so we know that the mass equals volume times density. So first we can find the volume. We say the volume, you can do each one separately and add them up. So for example, we can say the rectangular prism is simply 12 times 6 times 3. So that's 216 square centimeter. The volume of the rectangular pyramid, it's still RP, so prism and pyramid, for example, equals 1/3 the area of the base. The area of the base here is 12 times 6, right? Times the height, and they tell you, what was the height is 3? No, the height is 10. 12 over 3 is 4, times 6 is 24, times 10 is 240. So the mass equals the sum of the volumes, 456, times 2.5. Can we do that without a calculator? So this is 456 times 2.5. When you multiply by 2.5, it's as if you multiply by 10 and divide by 4. So if I divide that by 4, I get 114 times 10 is 1140 gram. Oops. Let's do the work, check our work. So 12 times 6 times 3. I didn't delete what we did before yesterday. And then 12 times 16 times 10 over 3. Oh, 12 times 6, not 16. Is 240. And now you add 216 plus 240. And you multiply that by 2.5. So you get 1140. So, okay, it was correct. Why did I second guess? I wasn't second guessing myself. I wanted to show you that it was correct. Okay, so that's the third part. Probably the proof took longer, but the other two were pretty straightforward, really. This one is 6 credits. It has like 3 parts. The first part says that's quadrilateral ABCD is graphed on the set. They give you the coordinates of the points. So we can write them down. So instead of going back and forth, so you can say -3 and 1. In fact, you can count. But since they give you those, that would be -3, -7. And this would be 6 and 5. And that would be 0 and 5. Segment EF is graphed with endpoints coordinates. E is -3, -3, and F is 3, 5. They tell you to prove that ABCD is a trapezoid. Okay, it's a quadrilateral. In order to prove that it's a trapezoid, of course, I'm going to look at these two sides and prove they are parallel, right? Because I know these are not parallel anyway. So we can find the slope of segment AD equals change in y, so 5 minus 1 over 0 minus negative 3 equals 4/3. Slope of BC is 5 minus negative 7 over 6 minus negative 3 equals 12 over 9. Simplify by 3, you get 4/3. AD is parallel to BC, hence ABCD is a trapezoid. Okay? That's the first part. Okay, we still have the same thing, so let me leave this. Use coordinate geometry to prove that EF is parallel to both. So we can find the slope of segment EF. Same thing as we did. Slope of segment EF equals change in y. So 5 minus negative 3 over 3 minus negative 3 again. Okay, equals 5 plus 3 is 8, and 3 plus 3 is 6. Simplifying by 2, you get 4/3. Same slope as segments AD and segment BC, hence parallel to them. Okay, I just want to do it quickly. Is EF half of AD plus BC? Use coordinate geometry to justify your answer. Okay, of course, we know it is, right? Because this is these two sides are equal and these two parts are equal, so that must be in the middle, but you need to use coordinate geometry. So we can find the length of segment AD by using the distance formula, 5 minus 1 square plus 0 minus negative 3 square equals the square root of 4 square plus 3 square equals 5, right? We know that that's Pythagoras. Measure of BC, again, 5 minus or 6, it doesn't matter, you start with X or Y, but be consistent. So it makes sense. Plus 5 minus, here I started with the Y. It really doesn't matter. In fact, you can even switch them because 5 minus 1 square is the same as 1 minus 5 square. It's not important, but it's usually better to be consistent. And I would have switched these two in the test. It's not wrong, but it's telling me I'm taking, the reason I wrote it like that, I don't want you to memorize. So the distance formula is the square root of x2 minus x1 square plus y2 minus y1 square. Well, you can make it backwards. You can make it y2 minus y1 square plus x1 minus x2 square. You can do whatever you want as long as the math is correct. But when you are consistent, it's easier even for you to check your answer. Okay, so this is the square root of, this is 9 square, is it? 6, yeah, 9 square plus, and this is 5, oh, I'm sorry, I did 6, 5 and negative 7. Okay, so 5 minus negative 7 is 12 square. Notice that if you multiply 3 by 3 and 4 by 3, you will get 5 times 3, which is 15. Or you can use the calculator. You can say 81 plus 144 is 225. Square root of 225 is 15. You can use the calculator for that. So 5 and 15. Now let's see the length of EF. It's the square root of x2 minus x1 square plus y2 minus y1 square equals 3 minus negative 3 is 6 square plus 8 square. And of course, this is twice as 6 is twice as 3 and 8 is twice as 4. So the answer would be twice as that, right? 6 square plus 8 square, 36 plus 64 is 100, and square root of 100 is 10. So EF is 10. 1/2 AD plus BC, the length of that, equals 1/2 times 5 plus 15 equals 1/2 of 20 equals 10. So that proves, so EF equals 1/2 of AD plus BC. And that completes the test. And as usual, I tell you, if you have any questions or any correction or comment, please don't hesitate to leave me a note. I'll try to get back to you as soon as I can. And if you don't have any questions, I wish you all the best in your test. I know it's coming in a few days. So good luck and have a great day. Bye.